M16 rifle is not only essential to modern military forces, but also a marvel of engineering. Produced by the millions annually, it's crafted to meet the high demands of reliability and versatility.
The father of all black rifles that will take you back to 1967.
Creating the M16 goes beyond just assembling parts. It involves expert design, skilled engineering, and close collaboration with the military, all supported by advanced technology and strict quality checks. In this video, we'll dive into the fascinating process of the making of M16 rifles. The M16 holds a key spot in military history. It started its journey during the Vietnam War and has become a crucial weapon in military arsenals worldwide. Its roots go back to the late 1950s, when the US military needed a new weapon that was powerful, yet easy to carry through the dense jungles of Vietnam. This quest led to the creation of the M16, which changed modern warfare. The story begins with the AR-15, designed by Eugene Stoner, firearms engineer at Armalite Corporation. Stoner's design was revolutionary, using lightweight materials like aluminum and fiberglass instead of traditional steel and wood. This made the AR-15 lighter and easier to handle, especially in Vietnam's tough terrain. The AR-15's success grabbed the attention of the US military, leading to its modification and adoption as the M16 during the Vietnam War. The M16 replaced the heavier M14 as the standard rifle for American troops. However, early M16 models had issues with jamming, a big problem in Vietnam's humid, muddy conditions. These problems were mainly due to ammunition issues and a lack of proper cleaning kits for soldiers. Over time, these issues were fixed with several upgrades, including a chrome-plated chamber and bore, which reduced corrosion and fouling. These improvements established the M16's reputation as a reliable and effective weapon. The M16 is known for several key design features that make it effective and adaptable in combat. Made mainly from aluminum alloys and plastic composites, the M16 is much lighter than many traditional rifles. This lighter weight improves mobility and reduces fatigue, crucial for long operations requiring quick movements and extended engagements. The M16's modularity is another significant feature. It has interchangeable parts like barrels, handguards, and sights, allowing customization based on mission needs and personal preferences. This makes maintenance and upgrades easier and supports various attachments, reflecting the growing emphasis on versatility in modern warfare. The M16 has evolved to meet changing combat needs. The M16A1, introduced during the Vietnam War, was praised for its accuracy, but had reliability issues. The M16A2, introduced in the 1980s, fixed these issues with a heavier barrel for better accuracy, a new flash suppressor, and a more robust rear sight. The M16A4, introduced in the late 1990s, added a removable carrying handle and a rail system for mounting optics and accessories, showcasing its adaptability. The legendary M16, materials and components. Ever wondered why the M16 is both durable and legendary? Let's dive into the materials that make this iconic rifle stand out. The M16 uses aluminum alloys, particularly forged 7075 Teak 6 aluminum for its upper and lower receivers. Aluminum is chosen for its light weight, corrosion resistance, and strength, allowing the rifle to weigh around 6 to 7 pounds. This lightweight makes it easier for soldiers to carry and enhances their overall combat effectiveness by allowing them to carry more ammunition. Steel is used where extra strength is needed. For instance, the barrel is made from steel and often chrome-lined to resist wear and corrosion. The bolt and bolt carrier, which are essential for the rifle's firing mechanism, are also made from high-grade steel to withstand repeated firing stresses. Polymers and composites are used for parts like the stock, handguards, and pistol grip. These materials are light, durable, and resistant to environmental factors. They allow for complex shapes and contribute to the rifle's modularity. For example, the handguards are made from high-strength polymers to withstand heat and impact, while the use of polymers allows easy customization and integration of accessories. The M16's manufacturing process. The M16 involves advanced technology and strict quality control to ensure each rifle meets high standards. Precision is vital in M16 production. Components are made to exact specifications to ensure proper fit and function. This is achieved using advanced machining techniques and quality control checks. Modern manufacturing uses CNC machines to produce parts with high accuracy. These machines create complex shapes and details essential for the rifle's performance. New materials and alloys are also tested to ensure they meet the demands of modern combat. Quality control is crucial in M16 manufacturing. Each rifle undergoes thorough inspections and tests, including function checks, accuracy assessments, and durability evaluations. Any component not meeting standards is reworked or replaced to ensure overall quality. The M16's lasting impact. The M16 rifle has made a lasting impact on military history. Its design and evolution reflect changing combat needs and the search for better, more effective weapons.
The M16 and its derivatives like the M4 has been the US Army's weapon of choice.
The rifle's lightweight design, modularity, and advanced materials have made it valuable in various combat scenarios. The M16 has also influenced the development of future infantry weapons, setting standards for lightweight construction, modularity, and adaptability. Its innovations continue to shape modern weapon design. Assembly and testing. Crafting precision. After the M16's components manufactured, they come together in the assembly process. This stage demands meticulous attention to detail.
Bar stock goes into a machine for hammer forging. The hammer forging process, which takes just 3.5 to 4 minutes,
to ensure each rifle functions perfectly and meets all performance specifications. Once assembled, every M16 undergoes a series of rigorous tests, including function checks, accuracy assessments, and durability evaluations. These tests are essential to confirm that the rifle performs reliably under a range of conditions. The M16's lightweight and durable construction benefits from advanced materials like aluminum alloys, steel, and polymers. Sophisticated manufacturing techniques such as CNC machining ensure precision and consistency. Furthermore, a comprehensive supply chain management strategy and rigorous quality control enhance the rifle's performance. Looking ahead, the M16's blend of innovation, precision, and quality continues to set a benchmark for modern firearms. Its legacy not only highlights its role in military history, but also influences the design and development of future weapons. Fusion of tradition and technology in M16 manufacturing. The M16 rifle represents the perfect blend of traditional craftsmanship and cutting-edge technology. This fusion ensures that each rifle meets rigorous performance standards and operates flawlessly in various environments. Understanding how these elements combine reveals the detailed process behind this iconic rifle. Material preparation and precision engineering. The production of an M16 begins with selecting and preparing raw materials. The primary materials, aluminum and steel, are processed into components needed for the rifle. When aluminum and steel arrive at the factory, they are prepared for machining. Large billets or sheets of these metals are cut into manageable sizes and subjected to treatments to enhance their workability and durability. Precision is key in manufacturing the M16, and computer numerical control, CNC, machining plays a crucial role. CNC machines use computer software to control cutting, drilling, and shaping with high accuracy. This technology ensures that components like the upper and lower receivers are manufactured to exact specifications, producing consistent, high-quality parts on a large scale. CNC machining also allows for the production of interchangeable parts. This modularity enables easy repairs and upgrades, as components fit together seamlessly, regardless of when or where they were made. Automated assembly and quality assurance. After machining, components move to automated assembly lines, which streamline production while maintaining high quality. The assembly lines in M16 manufacturing facilities are highly organized. Components are moved through various stages by robotic arms and conveyor belts. With each station responsible for specific tasks, automation reduces human error and speeds up production, ensuring that each rifle is assembled with precision. Quality control is integral to the assembly process. Each rifle undergoes function checks, accuracy assessments, and durability tests to ensure it meets performance and safety standards. Any rifle that fails to meet these standards is reworked or discarded, maintaining the M16's reputation for reliability, legacy, and future of M16 manufacturing. The M16's production reflects a blend of traditional craftsmanship and modern technology. The careful selection of materials, precision engineering, and automated assembly contribute to the rifle's legacy as a reliable and versatile weapon. As technology advances, M16 manufacturing may evolve to incorporate new techniques and materials. However, the core principles of precision engineering and quality control will remain essential for maintaining the rifle's performance and reputation. The M16's legacy demonstrates how combining traditional skills with modern technology can create a weapon that meets high standards of reliability and performance. Its influence extends to future firearm designs, setting a standard for innovation in weapon manufacturing. The evolution and impact of modular design in M16 manufacturing. The M16 rifle is renowned for its modular design, which has revolutionized both its manufacturing process and functionality. This design approach enhances assembly efficiency, customization, and large-scale production. The M16's modular design uses standardized, interchangeable parts across different models. This compatibility streamlines assembly and allows various configurations to be produced on the same assembly line, increasing efficiency and consistency. Automation in the assembly of standardized components accelerates production and ensures quality. Robots handle repetitive tasks with precision, reducing human error. Modular design also simplifies quality control by making it easier to identify and address defects without disrupting the entire production line. Standardized components allow manufacturers to achieve economies of scale. Producing large quantities of the same parts lowers production costs and streamlines supply chain management, benefiting both manufacturers and end users. The M16's modularity makes maintenance straightforward. Interchangeable parts can be replaced or upgraded with minimal specialized knowledge, allowing for quick repairs in the field or at maintenance facilities. This reduces downtime and keeps the rifle operational. The rifle's modular design also supports customization. Components like the handguard, stock, and sights can be modified to meet specific mission requirements or personal preferences. This flexibility enhances the rifle's adaptability to various combat scenarios. The M16's modular design has allowed for incremental improvements over time. Changes from the M16A1 to the M16A2 and M16A4 demonstrate how modularity facilitates updates without redesigning the entire rifle. The M16's modular approach has influenced other firearms and military equipment. The principles of modularity and standardization are now widely adopted in the industry, leading to more versatile and efficient designs. Rigorous testing and validation. Before any functional testing begins, each component of the M16 undergoes a thorough visual inspection and precise measurements. This initial phase is crucial to ensure that each part adheres to exact manufacturing specifications and is free from defects. Components are checked for visible defects, such as cracks, corrosion, or incorrect finishes. This helps catch issues early and prevents defective parts from moving further along in the production process. Tools like micrometers and calipers are used to measure critical dimensions, such as barrel alignment and chamber dimensions. Accurate measurements ensure that parts will fit and function correctly when assembled. Functional tests. The rifle is fired at various ranges using test targets to measure grouping and precision. This ensures that the M16 delivers accurate shots and meets performance standards for targeting. The rifle undergoes continuous firing tests to evaluate its ability to function without malfunctions. It is also tested under simulated real-world conditions, such as extreme temperatures, dust, and mud, to ensure it operates reliably in diverse environments. This includes checking the operation of the firing mechanism, magazine feed, and safety features. Components like the bolt carrier group, trigger mechanism, and magazine release are thoroughly tested to ensure smooth operation. Endurance tests. The M16 is subjected to prolonged periods of firing, often with high round counts, to test its ability to withstand sustained use. This helps identify wear and tear on critical components, like the barrel, bolt, and receiver. Components are inspected for signs of degradation to ensure the rifle remains reliable over time. This testing helps prevent potential issues from emerging during extended use. Environmental tests. The rifle is exposed to high humidity, freezing temperatures, and other environmental extremes. This simulates conditions it may encounter in different terrains and climates. The rifle is tested in sandy and dusty environments to assess its resistance to clogging and jamming. This ensures it remains functional in challenging conditions. Quality control measures. Quality control is integrated throughout the production line with dedicated inspection stations. Precision instruments and testing equipment are used to perform thorough inspections at key points. Inspectors check for defects, dimensional accuracy, and assembly quality. Any identified issues are addressed immediately to maintain high standards. Parts or rifles that do not meet quality standards are reworked or discarded. Rework and scrapping. Parts or rifles failing to meet standards are handled as follows. Defective parts are repaired or modified to meet specifications. This process helps reduce waste and ensures parts are brought up to quality standards. Parts that cannot be salvaged are discarded and replaced with new ones. This ensures that only rifles meeting high standards are delivered. Sourcing high-quality materials is critical. Manufacturers collaborate with a network of reliable suppliers to ensure materials meet required standards. Regular audits and inspections monitor supplier quality. To prevent supply chain disruptions, manufacturers may maintain reserves of critical materials. Ensuring a steady production flow, ongoing efforts are made to enhance the M16's quality and performance. Feedback from field usage, customer reviews, and research and development efforts contribute to refining the design and manufacturing processes. Continuous improvement initiatives integrate advancements in technology and materials to address issues identified in testing and enhance overall performance. Ensuring field performance. The rigorous testing and quality control processes ensure that the M16 performs reliably in real-world conditions. The M16's modularity allows for customization with different accessories and modifications. This adaptability meets various mission requirements and enhances its effectiveness in diverse scenarios. The M16's reliability in combat is a direct result of its thorough testing. The rifle performs consistently under challenging conditions, validating the effectiveness of the testing processes. Manufacturers provide maintenance programs, training, and spare parts to ensure the M16 remains operational throughout its service life. This support helps keep the rifle in optimal condition and enhances its longevity. The commitment to quality and continuous improvement reflects the M16's importance in modern military operations. As technology and operational requirements evolve, the principles of precision engineering, modularity, and rigorous testing will continue to be crucial in developing effective and reliable weapon systems. Contracts from government entities, such as the U.S. Department of Defense, often involve substantial quantities of rifles, which can total hundreds of millions of dollars. These bulk orders provide a steady demand that drives the production of rifles at scale. Typically, these contracts are multi-year agreements that include terms for updates, maintenance, and training. Long-term contracts allow manufacturers to invest in advanced production technologies and maintain high-quality standards. The substantial volume of orders helps justify the high costs associated with sophisticated assembly lines and stringent quality control measures, ensuring that production facilities are optimized for efficiency and precision. Collaboration between manufacturers and military. Detailed discussions between engineers and military experts help address operational requirements, environmental considerations, and any necessary modifications based on recent combat experiences. This ensures that the rifle is well suited to the needs of the military. Through this collaboration, the design and functionality of the M16 can be adjusted. Modifications might be made to enhance performance in particular environments or to integrate new technologies, ensuring the rifle remains effective and relevant. The global distribution of the M16 involves several key strategies. Large government contracts ensure that rifles are produced in the required quantities and meet high standards. Governments are responsible for overseeing the distribution of rifles to appropriate military units. Effective distribution requires meticulous planning and coordination, including transportation, storage, and handling, to ensure rifles arrive in good condition and on time. International agreements. Global distribution often involves international agreements and partnerships. These can include agreements between countries and manufacturers to supply M16s to allied nations or other partners, enhancing international military cooperation. Supply chain management. Efficient supply chain management is vital to maintaining the flow of materials and components necessary for production. Manufacturers must ensure a reliable supply of raw materials and manage inventory effectively to prevent delays. The impact of production and distribution strategies. Production efficiency, large-scale contracts, and investments in advanced technologies ensure that each M16 is manufactured to exacting standards, maintaining reliability and performance. Careful planning and logistics ensure that rifles are delivered efficiently and securely, enabling military forces to deploy and utilize their weapons effectively. Distribution of the M16, ensuring global reach. Modern production lines, often highly automated, ensure precision in manufacturing. This automation is crucial for meeting the rigorous standards required for reliability and performance. Continuous quality control checks during production ensure that every M16 meets the required specifications, reducing the risk of defects. Planning and coordination. Understanding the specific needs of different military units globally helps tailor the distribution strategy. Addressing logistical challenges such as infrastructure limitations and geopolitical factors is essential for successful delivery. Balancing the urgency of deliveries to conflict zones with routine shipments to other locations ensures that all needs are met efficiently. Transportation methods. Preferred for urgent deliveries due to its speed. This method is particularly important for conflict zones or remote military bases where rapid deployment is critical, used for larger shipments, and is cost-effective for non-urgent deliveries. Sea transport is suitable for bulk shipments where speed is less critical. Both methods require close monitoring and tracking to ensure timely and safe delivery. Security measures. Rifles are packed in tamper-evident and damage-resistant containers to safeguard against theft and damage. Shipments to high-risk areas may be accompanied by security personnel to ensure safe delivery. Shipping routes and schedules are kept confidential to minimize the risk of interception or theft. Customs clearance and regulatory compliance. Detailed documentation is prepared to meet the requirements of both exporting and importing countries. This includes licenses, export controls, and compliance with international arms trade regulations. Manufacturers and logistics providers work with customs authorities to expedite clearance and avoid delays. Final distribution. Rifles are received by local military logistics units, which are responsible for the final distribution to military units. In regions with poor infrastructure or ongoing conflicts, additional security measures, such as armored vehicles or military escorts, may be required to ensure safe delivery. Final considerations. The M16's journey from production to deployment involves a complex network of contracts, technical collaboration, and strategic distribution. Each phase, from manufacturing to final delivery, is designed to ensure that the rifle remains a dependable and effective tool for armed forces around the world. By managing contracts effectively, collaborating closely with military experts, and ensuring secure and efficient distribution, manufacturers and governments can maintain the M16's reputation as a reliable and valuable weapon system. M16 rifle is one of best creation of all time, produced by the manufacturers every year. What do you think about it? Please leave your thoughts in the comments, and don't forget to like, share, and subscribe.